So today we're going to talk about rationalizing denominators. Now there's two basic forms of denominators that you're going to come across, simple denominators and then denominators that are actually binomials. So we're going to look at simple denominators first. So the first one we're going to look at is simple denominators. So here we have just a basic term, and I want to get it so that the denominator is a rational number and doesn't have this radical in it. Well, since I have the square root of 3, you might recall that when we are rationalizing these, we multiply by something that's called the rationalizing factor. In this case, that rationalizing factor is the square root of 3. So I'm going to multiply by a special form of 1 that has this rationalizing factor in it, the square root of 3. And the reason is because when I multiply the square root of 3, the square root of 3 times this square root of 3, I'll get the square root of 3 squared. And when I square a square root, it has that identity property that gives me back just the number 3. So we already know that this times this will just be 3, and 3 times the 2 will give me 6. So let's write this out. On my numerator, I have 5 times the square root of 3. And in my denominator, I'll have 2 times the square root of 3 squared, which we just saw was 3. So this whole thing is basically 5 square root of 3 over 6. That is a rationalized fraction. Now, in the denominator here, we're also going to multiply by a rationalizing factor, but the rationalizing factor is going to be different. I need to multiply by something that will cancel out with this cube root. Well, things that cancel cube roots are cubes. So just like the square root had to be squared, the cube root's going to have to be cubed. So right now I have one factor of 5 when I'm going to need, one factor of the cube root of 5 where I'm going to need 3 factors of it. So in this case, my rationalizing factor will be the cube root of 5 squared, the cube root of 5 squared. And the reason is when I multiply this 1 cube root of 5 times these 2 factors of cube root of 5, I'll end up with the cube root of 5 cubed. And just like with the square root and the square, the cube root and the cube will cancel each other out or undo each other and leave me with 5. So this whole fraction will become 2 cube root of 5 whole quantity squared. And recall that also with those exponent properties, I could rewrite this as the cube root of the quantity 5 squared over, and we just saw this denominator will now reduce to 5. And 5 squared is 25, so I can simply write this also as 2 cube root of 25 over 5. It's my rationalized fraction. Now, in general, whatever type of rationalizing factor you're looking for, it's always going to be 1 power less than the index of the radical. So a rationalizing factor in general will always be 1 power less than the radical. So what that means is, in context, if I'm looking at a specific example, like say I have 1 over the 4th root of 7, in this case my rationalizing factor, which I'll just abbreviate as RF, my rationalizing factor will be the 4th root of 7 cubed, so that when I multiply these together, I'll have the 4th root of 7 to the 4th, which will give me just 7 in my denominator. So that's how you can determine your rationalizing factors. Now, the other type of equations that you'll have to, expressions that you are rationalizing will be ones where you have a binomial in the denominator. Now, when we have a binomial with radicals in it in the denominator, if I want to rationalize it, I'm going to have to use a process of multiplying by the conjugate. Now, recall from previous math classes that you've taken, the conjugate of a number is basically, or a binomial is basically the exact same expression, only difference is that the signs are opposite. So these two expressions are conjugates of each other. Now, what's nice about conjugates is that when I multiply them together and FOIL them out, I get this expression, and if you notice that the two middle terms here are exactly the same, except their signs are opposite. So these two middle terms are going to cancel out, and it leaves me with a squared and the square root of b squared. So when I simplify those, I end up with this expression, a squared minus b. And if you notice, there are no radicals in that expression. So by multiplying by a conjugate, I eliminate the radicals in the binomial. So let's see that in the context of this example. First, I'm going to identify what the conjugate is, and it's basically the same expression involving the 3 and the square root of 7, but it will have an opposite sign in between. So since this is a plus, this will be a minus. Now notice the sign of the 3 is still the same. The only thing that's changing is the sign between the two. And in order to keep this expression the same, I'm really multiplying by a special form of 1. So I'm going to have this conjugate in both the numerator and denominator, just like I did with my rationalizing factor in the previous examples. So I'm multiplying these two expressions together. When I multiply the numerators, I end up with 2 times this whole 3 minus the square root of 7, shenanigans. And in the denominator, I'll have the product of these two conjugates. Now, as we just saw, when I multiply two conjugates, I end up with this special binomial situation. So I'll have my first term squared, which will be 9, and I'll have my second term squared, which will be the square root of 7 squared is still 7, and I will be subtracting those two values. In the top, I still have some work I have to do by distributing that 2. And then I also need to simplify my denominator. Now notice that 9 minus 7 is just 2, so this whole expression is 2 times 3 minus the square root of 7 divided by 2. And since 2 is a factor of both the numerator and denominator, they will reduce, and this entire number reduces to 3 minus the square root of 7. Simplified version. Technically, that's 3 minus the square root of 7 over 1, but anything over 1 is just itself. So now those two methods for simplifying is multiplying by that rationalizing factor, if it's a simple denominator, a monomial, and multiplying by the conjugate when it's a binomial.